everybody, welcome to Sangam Tutorials SP Gubbi online classes for NCERT and CBSE 9th standard classes for mathematics and science. So in this session you are going to learn the theory of factor theorem. So at the end of this session you will be a master in factor theorem, that is the theoretical background. So once you are a master in theoretical things, you can easily, it's a cakewalk, you can easily solve problems on factor theorems, right? So before starting factor theorem, just I want to tell you one thing. So here factor theorem is just an extension of remainder theorem, or it is an application of remainder theorem. Please keep it in your mind. So very important, here very important thing is, remember this, factor theorem is an extension of remainder theorem, or the factor theorem is an application of remainder theorem. So here we have already done the remainder theorem. So if a linear polynomial in the form of x minus a divides the polynomial p of x, we are going to get a remainder. So if that remainder is equal to 0, then we say that the linear polynomial x minus a is a factor of p of x, and in other words we also say that p of x is a multiple of x minus a. I hope you are able to grasp me. Once again I will repeat. So in the remainder theorem we have learned that if a linear polynomial in the form of x minus a divides a polynomial p of x whose degree is greater than or equal to 1, then we get the remainder. So if that remainder is equal to 0, then we say that x minus a is a factor of p of x. If the remainder is not equal to 0, then we say that x minus a is not a factor of p of x. See, how to get that remainder? How to get that remainder? So in the remainder theorem we used to find the remainder without doing the actual division. So when the polynomial was given and x minus a was a linear polynomial, so we used to divide the polynomial p of x by x minus a. So the 0 of x minus a, when substituted in p of x, the value what we used to get was the remainder when x minus a divided p of x. That is what we have learnt in the remainder theorem. I hope you remember, recall, you are able to understand what I am telling you. So if you are not able to understand, do one thing, stop the video here itself, don't worry, stop it, go back to the remainder theorem, see that once and come back to this video again. You will enjoy it, right? If you have seen, no problem, we will continue. So once again, if x minus a is a linear polynomial and p of x is a polynomial of degree greater than or equal to 1, and if x minus a divides p of x by long division process, the last what we get the number or a constant or a polynomial whose degree is less than or equal to or less than the divisor, the degree of the remainder is less than the divisor, we used to stop the division and we would say that that is the remainder. So here, instead of doing long division method, we took the help of the remainder theorem where we equated the linear polynomial x minus a to 0, and we found out that is x is equal to some value, and we substituted that value in the polynomial, and after simplification, at last what the constant we used to get, or the constant we used to get, that would be the remainder. That is nothing but the remainder theorem, right? So just I am trying to recall the things what we had done in the remainder theorem. Now, so here the remainder what we get when we divide a polynomial p of x of degree greater than or equal to 1 by a linear polynomial, the remainder what we get here, if it is 0, directly, if remainder is 0, it is equal to 0, then we get to know a beautiful relation between the divisor and the quotient. That's a very beautiful relation between the divisor and the quotient. If the remainder is not equal to 0, then also we are going to get a beautiful relation between the divisor and the quotient. So that is what we are going to learn in this factor theorem. That's the concept, right? So once again, listen to me very carefully. X minus a is a divisor, p of x is a polynomial, that is called dividend. So here, if x minus a divides p of x by giving remainder 0, there comes a new relationship between the divisor and the quotient. If the remainder is not equal to 0, then there comes out a new relationship between the divisor and the quotient. So that is what we are going to learn here, right? So we are going to learn the factor theorem by taking a very simple numerical example. You have to observe the class very carefully, listen to me very carefully. At the end of this class, you will be a master in factor theorem, right? Now, let us take a real number 12. I'm going to take 12. Okay? I'm going to divide this by 2. So 2 6 it is 12. Remainder is 0. Remainder is 0. Right? Very nice. 12 is the dividend, 2 is the divisor, 6 is the quotient, and 0 is the remainder. Done? Sir, we know this. We have done thousands of problems on this. We know this. Good. But what I am going to tell you now, you don't know this. You are going to learn this. Right. So here 12 is the dividend, 2 is the divisor, 6 is the quotient, and 0 is the remainder. Now, as 12 is divided by 2, we have got the remainder as 0. So, if you observe, 2 is a factor of 12. Factor means what? The list of numbers which can divide a given number by giving remainder 0 are called the factors of the number. For example, 12 has factors like 1, it has 2, it has 3, it has 4, it has 6 and 12 itself. Okay, right. So 1, 2, 3, 4 and 6 can divide 12 by giving remainder 0. Therefore, the list of those numbers which are less than the given number, which can divide the given number by giving remainder 0 are called the factors of that number. So here you can see, as 2 divides 12 and we get the remainder 0, we say that 2 is a factor of 12. Yes, 2 is a factor of 12. Yes, exactly. Right? Second point. 6 is also a factor of 12. 6 is the quotient. Yes, 6 is also a factor of 12. So, if 2 divides 12 by giving remainder 0, then the divisor is a factor of 12. Quotient is also a factor of 12. Right? Once again, if a number divides another number by giving remainder 0, then divisor is a factor of 12 and 6 is, that is the quotient, is also a factor of 12. I hope you got the point. If the remainder is 0, divisor is a factor of the dividend, quotient is also a factor of the dividend. 2 points. I will take up another example. I will take 15. I am going to divide this by 2 again. 2 7s 14, remainder is 1. Remainder is not 0, in the sense it is a non-zero number. So since remainder is not equal to 0, therefore 2 is not a factor of 12, that is 15. Let us list out the factors of 15. Who can divide 15 by giving remainder 0? 1 can do that, 2 cannot do it, 3 can do it, 3 5s are 15, 5 can do it, and next number is 15 itself. Okay, we will leave this. So 1, 3 and 5 are the factors of 15 here. So 2 is not in the list. So therefore, when we divide 15 by 2 and we do not get the remainder as 0, then we say that 2 is not a factor of 15. Yes, in the factor list of 15 we do not find 2. And also here 7 is not a factor of 15. 7 is also not a factor of 15 because 7 cannot divide 15 by giving remainder 0. So right, so 1, 3, 5, among these factors 2 is not present. So when you divide a number by another number and the remainder is not 0, surely divisor is not a factor of the dividend, and quotient may be at certain times, may be or may not be the divisor, that is maybe or may not be the factor of the dividend. For example, if I take 13 here, to 6 it is 12, remainder is 1. So again you can see 2 when it divides 13, the remainder is 1. So here 2 is not a factor of 13, 6 is not a factor of 13. So therefore when the remainder is not 0, the relation between the quotient and the divisor is that divisor is not a factor of the dividend. So that is, quotient is also not a factor of the dividend. But there are two chances here. One is when you divide a number by another number and the remainder is not 0, sure, compulsory divisor is not a factor of dividend, but the quotient may be or may not be the factor of the dividend. So this is you have to understand. Done? Okay. Now I am going to come to certain conclusions. Very important, certain conclusions. Very important. You have to listen to me. If a number divides another number by giving remainder 0, then divisor is a factor of dividend, quotient is a factor of dividend. Two statements. Divisor is a factor of dividend, quotient is also a factor of dividend. You have to remember this. When we divide a number by another number in such a way that the remainder is not equal to 0, then we say that divisor is not a factor of dividend, quotient may or may not be the factor of the dividend. So these 4 things you have to remember. Right? Sure? Done. Sir, we know all these things. A very simple new things we have learned here. Yes, the same property what it's happening with the numbers here on the board, the same property applies for polynomials also. Same thing applies for polynomials also. Done? Right. Very simple. We will go like this. Here is, we have a polynomial p of x as the dividend, we have g of x as the divisor, and we have q of x as the quotient. Some process happens and we are going to get the remainder as r, and r in this case let us take it as 0. So when a polynomial g of x divides the polynomial p of x by giving remainder 0, then sure, what happened here, the same thing also happens here. So g of x will be a factor of p of x, q of x will also be a factor of p of x, so when the remainder is equal to 0. Right? What happened with the numbers? Same thing happens with the polynomials. But here, g of x, what the divisor we are considering here, should be compulsory a linear polynomial. That is, g of x should be in the form of x minus a. That is, it should be a linear polynomial. So, factor theorem is applicable only if the divisor is a linear polynomial. right? So once again, we have a linear polynomial x minus a in the form of x minus a, which divides p of x by giving remainder 0. In this process, q of x is the remainder. So q of x is the quotient. If the remainder is 0, then g of x or x minus a will be a factor of p of x, and q of x will also be a factor of p of x, and remainder is 0. Now, if you come to this case, in this case, p of x is a polynomial and x minus a or g of x is the divisor. So, if x minus a or g of x divides p of x with quotient some q of x something, and the remainder is not equal to 0. The remainder is not equal to 0, then we say that x minus a or g of x is not a factor of p of x, and q of x is also or maybe or may not be the factor of p of x. So this is for sure. See, what I am telling you here in both the cases is nothing but called the factor theorem. Very simple. That is itself is factor theorem. Once again, I will repeat this. If g of x, which is in the form of x minus a linear polynomial, divides p of x by giving remainder 0, then we say that g of x or x minus a is a factor of p of x, and q of x is also a factor of p of x, right? In the second case, if x minus a or g of x, a linear polynomial, divides the another polynomial p of x in such a way that the remainder is not equal to 0, then we say that x minus a or g of x is not a factor of p of x, and q of x may be or may not be the factor of p of x. This is what we call factor theorem. That's all. That's all. Don't think any other thing here. So, basically, we are going to prove this. I am going to prove the factor theorem by taking the help of remainder theorem, because the extension of remainder theorem is the factor theorem, or the application of remainder theorem is the factor theorem, right? So I am going to just prove this, right, by remainder theorem. By remainder theorem, p of x is equal to x minus a into q of x plus remainder is always p of a. Remainder is always p of a, because x minus a is the divisor. If x minus a is equated to 0, x is going to become equal to a, and when you substitute this value of a in p of x, then the remainder will be p of a. So p of a is equal to x minus a into q of, okay, let it be x, p of x is equal to x minus a into q of x plus p of a. So p of x is equal to, when you substitute the value of a in place of x, it is going to become p of a. So it is understood that the remainder is p of a. According to the remainder theorem, p of a will be the remainder. So therefore, okay, right, p of x is equal to x minus a into q of x plus, this p of a should be compulsory equal to 0, because the remainder is 0, the remainder should be 0. So p of x is equal to x minus a into q of x, we are left over with. So you can easily observe p of x is equal to x minus a into q of x, that is the divisor into quotient plus remainder. As the remainder is 0, two things remain, that is divisor into quotient. So this into this gives you p of x, means this is a factor of this and this is also a factor of this. Something like, I can tell you 6 is equal to 2 into 3. So here you can see, if you take p of x as 6 and x minus a as 2 and q of x as 3, then 2 divides 6, 3 also divides 6. That means 2 is a factor of 6, 3 is also a factor of 6. In the same manner, this has come generally. So if p of x is equal to x minus a into q of x, so therefore if p of a is equal to 0, that is P of A is equal to 0, that is remainder is 0, then x minus A is a factor of P of x. So this is the factor theorem. So here the converse of this statement is also true, right? For example, if x minus A is a factor of P of x, then according to the remainder theorem, P of x is equal to x minus A into Q of x plus, here, okay, if x minus A is a factor of P of x, then P of x is equal to x minus A into Q of x. Here we are not going to take the remainder because remainder is already equal to 0. So therefore P of A, when we substitute here, that is in place of x, if we substitute A, then it becomes A minus A into Q of A. So P of A is equal to A minus A is 0, 0 into Q of A it becomes, so P of A is equal to 0. So if x minus A is a factor of P of x, then P of A is equal to 0, and if P of A is equal to 0, then x minus A is a factor of P of x. So both the things are, that is the theorem as well as its converse, both are important. If P of A is 0, that is if remainder is 0, then x minus A is a factor of P of x. If remainder is 0, x minus A is a factor of P of x. And if x minus A is a factor of P of x, if x minus A is already a factor of P of x, for any value of Q of x can be any polynomial, for any value of Q of x, then P of A is equal to A minus A into Q of A, that is in place of x we are going to substitute A. So P of A is equal to A minus A is 0, 0 into Q of A. So we are left with 0 into Q of A is 0. So that is, if x minus A is a factor of P of x, then P of A will be compulsory equal to 0. So this is what we call the factor theorem. So very important, both the statements you have to remember here. This is the first statement. If P of A is equal to 0, then x minus A is a factor of P of x, and if x minus A is a factor of P of x, then P of A is equal to 0. So these two statements you have to remember. So this is what we call the factor theorem, or the extension of the remainder theorem, right? I hope you enjoyed the entire theorem. From tomorrow's session we are going to solve very simple, very important numericals on factor theorem. So until that, stay home, stay safe and keep learning. Thank you.